The first one has all three angles. These little arrows mean it's inside, so you have three angles that are inside there. And this one here, you have an exterior angle. So you need to start and write an equation for each and then solve it. Okay, so what's the equation for this first one? What do all three angles add up to in a triangle, Lauren?
180.
180. So we're going to take 2x plus 2 plus 2x plus 2 plus 3x plus 1 and set it equal to 180. Okay, that's our equation. If you add up all your x's, you have 2x plus 2x is 4x plus another 3x is 7x. And then add your numbers together. 2 plus 2 plus 1 is 5. And the right side is still 180. All right? We're going to subtract the 5. And divide by 7. So you get 25. Now, after you get your answer, we can plug those x values in and find out what kind of triangle we have. Can you tell by the markings already that it's an isosceles triangle? You have this mark here and this mark here, so I know it's isosceles by sides. I'm going to plug my 25 in. That's 50 plus 2 is 52, and this angle would also be 52 in there. This one is 75 plus 1, so that's 76. So by angles, this is acute. Yes, it's an acute isosceles triangle. So they may have you go a step further. And name it, classify it by sides and angles. Okay. All right, this other one, you have an exterior angle. So the rule for the exterior angle here, it equals these two interiors that aren't touching it, the sum of them. So 6x minus 7 equals 2x plus 103 minus x. And then you just solve that equation. 2x minus x is x. You can subtract the x to the left. And you can add 7 to the right. And then you're dividing. So x equals 22. Again, I'm going to put this in. 22 times 2 makes this angle 44 degrees. 103 minus 22 is 81. And 44 plus 81 minus 180 gives me 55. So none of those angles are the same. So we have a scaling triangle, and they're all acute, so it's a scaling acute again. Or acute again, but scaling this time. Understand, if the angles don't match, the sides aren't going to match. Okay, they're connected. Okay. Do you understand when we do both? Add the 180 or set it equal to the two angles added? All right. So today we're going to talk about congruent triangles. Okay. And you'll have a worksheet today. But congruent triangles means they're triangles that have congruent sides and congruent angles. Okay? So these are all congruent shapes. Same size, same shape, everything equals in measure. Okay? They don't have to be the same orientation, or they don't have to be they could be rotated or slid around or whatever. So what is key when you're talking about congruent figures is the order the letters are written. So triangle ABC is congruent to triangle DEF, and notice the colors. So A corresponds to D. Those are congruent angles. B corresponds to E, and C corresponds to F. So if you're looking at not only the angles congruent, but if you're looking at side AB, it's going to be congruent to side DE. So even if you didn't have the pictures, you could write all those congruent statements. Side BC is congruent to side EF. Side AC is congruent to side DF. Understand how we can match them up? By the order of the letters. Okay? So you can just kind of pair them up. Very important that you write the orders of the letters correctly. Okay? I want to write that down. Order of the letters is very important. It doesn't matter. Notice that these triangles are reflected or rotated. Reflected and rotated. Okay. Order of the letters. The order of the letters is the key. You shouldn't even need to have the picture. Okay. To write congruent statements. So let's see what we get into here. Write a congruent statement for the triangle to identify all pairs of congruent corresponding parts. So it doesn't matter what the first triangle starts as. I'm going to say it's triangle PRQ, or PQR, let's go alphabetical. PQR. And we want it to be congruent to triangle. Now this is when it's important. What angle corresponds with P? L. Okay? And you can see it's marked with 3. What angle corresponds with Q? J. And then the last one would have to be the K. All right? Okay. Now, if I have this, let's not look at the picture anymore. Try and look at just the letters. Angle P is congruent to angle L. Angle Q is congruent to angle J. And angle R is congruent to angle K. Everyone agree with that? That's what we just talked about. Now, like I said, we're going to ignore this picture. I don't trust you to ignore it. All right. Tell me the sides. Just by looking at this. What sides are congruent?
PQ and LJ.
Okay, so line segment PQ is congruent to line segment LJ. Does everyone understand how she's getting it? Okay, Logan, give me another one. QR is congruent to JK. Good. One more, Clay.
Does it have to be 2?
It has to be 2 letters. So we did PQ and QR. How about PR? What is it congruent to? Very good. So everyone understands you can kind of just match up the letters. All right. Very, very good. Write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. Oh, I took the triangle away. So just write all the corresponding congruent statements you can. You should have 3 angle statements and 3 side statements. So it's angle A congruent to Mike. Good. And angle B, Josh. In, good. And angle C, Sabrina. Oh, Everyone get all the angles right? Okay. Now, sides. AB is congruent, Zach, to
MN.
very good. BC, Mandy, is congruent to no, good. And last, AC. And oh, yep. Okay, everyone good? We can do that. Very good. All right. In the diagram, DEFG is congruent to SPQR. So notice D is corresponding to S, E is corresponding to P, F is corresponding to Q, and G and R. Okay? Find the value of X. So 2x minus 4 is side QR. What side in the other figure corresponds to side QR?
FG.
FG. So those two sides are equal. So we would say 2x minus 4 equals 12. See how we did that? Okay. So you have to find the corresponding side because the measurements will be equal. And then you can write the equation and solve it. Everyone make sense? Okay. Find the value of y. Well, we have this angle here that has y, and it also has x. So let's replace our x with the 8, because that x is going to be the same value as this x. It's on the side. What does 6y plus 8 equal? 68, because q corresponds with angle f in the statement up there. So this angle is going to be the same as that angle 68. So 6y plus 8 equals 68. Subtract our 8 and divide by our 6. And we get y equals 10. Does that make sense? So you just have to match. Because there's going to be everything, all sorts of things labeled. Which ones do you want to use? Alright, make sense? Make sure when you're taking notes, you're drawing the figures as well. If the notes don't make any sense, all we're doing is writing equations down if you're not drawing the figures. Okay. Third angles theorem. This is kind of common sense. If you have two angles of one triangle that are congruent to two angles of another triangle, the third one has to be congruent also, right? They all have to add up to 180. So if these two equal these two, the third one has to be the same. So that's a theorem, okay? If angle A is congruent to angle D and B is congruent to angle E, then C has to be congruent to angle F. That's just kind of common sense, but it's a theorem. Okay, it's called the third angle theorem. All right, let's look here. Use the third angle theorem. Solve this. Okay. So we have this triangle. Let's get rid of our markings here for a second. If this is 45 and this is 30, what is this angle right here? In that big triangle, ACB. I'm looking, this has got to be 75, right? So this is the triangle I'm looking at. Okay, so this is 75 total, so this guy has to be 105, right? Big angle. Okay? That's 45, this guy's up here is 45. Again, we said this angle is 30, so this little angle is 30. So what is this angle here? Just this piece. You understand what we did? We're back. This piece is 30, this is 30. This is 45, this is 45. This is 45 and this is 30. This big angle is 75. Okay? That's a different color here. That big angle is 75. So how much is this piece? Right here. Now the big angle is how much, guys? 105.
So the little angle needs to be 75.
Yeah, the little angle needs to be 75, sorry. So this guy is 75. Okay? So we can find those by the third angle theorem. All right. Interchanging angles. It's confusing. Here we go. Let's try another one. Let's try the proof of it. Prove that the triangles are congruent. Now, write the proof, given all that stuff is congruent. Okay. So we're going to rewrite our given. Notice I'm having to write the three letter angle instead of just the one angle because we have so many in the C's and the A's. All right, so all of this stuff was given to us. All right? Okay.
Those proofs.
It's geometry, Zach. It's just part of this course. Okay. Now, in order for the two triangles to be congruent, all the sides and all the angles have to be shown congruent. Okay, right now we have two sides and two angles that are congruent. We just need to do statements for another angle and another side. Can I say that angle D is congruent to angle B? Why can I say that? Because I already said the two other angles were congruent. So I can automatically say by the third angle theorem that that third angle is congruent. If I've already got two, I can write the third one down automatically by that theorem. Okay? I have side AD is congruent to CB. Side BA is congruent to DC. The only side I have missing is that AC side, right? How can I say AC is congruent to AC? Think back to chapter 1. I am saying that AC is congruent to itself. What property is that? Reflexive property. When you say something is congruent to itself, it's a reflexive property. Okay? Now, very carefully, let's write the congruent statement. Triangle. Let's go. Oh, ACD. I already got it written down there. ACD is congruent to triangle CAB. Okay? And that is, I'm going to write congruent parts of congruent figures. Theorem. Okay. So if all angles and all sides are shown to be congruent, the figures themselves are congruent. All right. Make sense? All right. Properties of congruent triangles. The reflexive property of congruent triangles. Every triangle is congruent to itself. The symmetric properties, if triangle ABC is congruent to triangle DEF, then you can switch it around, and DEF would be congruent to ABC. And the transitive property also works. If triangle ABC is congruent to DEF and DEF is congruent to JKL, then ABC is also congruent to JKL. Okay, so those three properties that we learned in the chapter 1 still exist, still being used with figures. Okay. Same properties. Okay, that is it for the lesson, guys. I'm going to give you your worksheet. You can work on it. Actually work on it. Get the other one done too tonight. Show it to me tomorrow.